What's up, AP Chemistry? We are here to go through our empirical formula combustion problems. Now with these, we had to use our empirical formula techniques, but with an extra step. So here we go for number one. The problem gave me, I had to kind of read through to find the information I needed, 23 and some change grams of CO2 and 4.7-ish grams of water. It gave me some other numbers, but that was to throw us off. We really want to focus in on my carbon and my hydrogen. Now for my CO2, remember that's where the carbon from my hydrocarbon is hidden. I'm going to have to first change grams into moles, but I need to be cognizant of what I'm starting off with in grams. This time it's CO2. So when I use my periodic table to find my molar mass, it's of CO2, not just carbon, because we're not there yet. That's not what the problem said. These are a level up. So 44.01 grams for every 1 mole. Then my grams can diagonally cancel, which is awesome, but I need moles of carbon. I'm not there yet. I got moles of CO2. So now I have to use my chemical formula as a ratio of moles. A chemical formula shows us the ratio of moles. So now for every 1 CO2, there's 1 carbon in my mole amounts. That's what that's telling me there. I put this in my calculator because, oh goodness, I cannot do this in my head. I took mine out to a couple of decimal places, 0.5258 moles of carbon. If you went to more or less decimal places, that's okay. Then I do the same thing for my water. Remember, that's where the hydrogen in my hydrocarbon is hidden. These are kind of sneaky, hiding in the shadows type problems, sure. So what I'm gonna do is to take my water and I gotta change it into moles. And again, remember, this is H2O. So when I find my molar mass, it is of water. And so then my grams can cancel. For every 1 mole of water, there are 2 hydrogens present, 2 moles of hydrogens present, because again, that's what my chemical formula says, H2O. For every one of these entire pieces, I look to my formula, there's 2 hydrogens there for moles. I put that in my calculator and I get a number that looks pretty familiar, 0.52515 moles of hydrogen. Now I can just eyeball this. These are pretty much the same number, so I do have a 1-to-1 ratio. But if I want to be extra sure and kind of follow what we did yesterday, I could always divide by the smallest, and I do get confirmation that that's a 1-to-1 ratio. Question 2 is another combustion problem, as these all are. And for this one, it's a more simplistic one with just CO2 and water. That's just going to give us our carbon and our hydrogens. So here we go. 4.40 grams of CO2. I change it into moles using the molar mass from the periodic table. For every 1 mole of CO2, because again, I follow my chemical, that's what I'm in over here, there's 1 mole of carbon. I put that in my calculator and I get 0.09997 moles of carbon. I do the same thing for water. 2.70 grams of water, change it into moles. For every 1 mole of water, this entire thing, it's gonna break off into 2 hydrogens, 2 moles of hydrogen. So then I put that into my calculator and I get what you can see here. Since for this one, I can't quite eyeball the ratio for this, I'm just going to be safe and divide by the smallest. So I'm gonna divide each of these by 0.099, again, because I can't see the ratio right away. And that gets me my whole number ratio. Things combine in whole number ratios, not in a 0.09 to 0.2 ratio, in a whole number. So that's how I get it over here. That's where the CH3 comes from. Cool. Lastly, for question 3, again, rinse and repeat from the first 2. I have my grams of CO2 and water. I change it into moles, change it into moles of the chemicals I'm interested in, and I get these numbers. This one, I can eyeball. They're both pretty much the same number, so I must have a 1-to-1 ratio. But just in case, if I can't see that, or if I'm just looking for that extra reassurance, I can always divide by the smallest just to make sure it is a 1-to-1 ratio, and it totally is. Cool. Then we move on to part 2. Now here's question 4. On an old worksheet we did was number 6, but this is our question 4. So with this, oh my goodness, now this is our most complex of problems. Carbon, hydrogen, and oxygen. So here's what I'm going to have to do is I'm going to have to figure out for my grams of CO2, not how many moles of carbon do I have, but how many grams of carbon do I have? Because remember we have that subtraction step. So when I do that, 44.01 grams for every 1 mole. For every 1 mole of CO2, there is 1 mole of carbon. And for every 1 mole of carbon from the periodic table, there's 12.01 grams. So when I put that in my calculator, I get 5.17-ish. I took mine out to a couple decimal places here, whatever, grams of carbon. I do the same thing with my water. This time, remember, we have to go to grams. 18.02 grams for every 1 mole. For every 1 mole of water, there are 2 moles of hydrogen. And for every 1 mole of hydrogen, again, because this is a single atom here, singleton hydrogen, it's not diatomic, we're not saying and oxygen gas, these are singletons, there's 1.01 grams of it. A super common mistake is to have something else than 1.01 on the top of this last step. I put it in my calculator and I get 0.8686. Okay, so now I have that total mass. The entire sample was 12.915 grams total. Now that total included my carbon grams. It included my hydrogen grams, but this is a tricky one where it also includes some oxygen grams. So I have to solve over here to figure out that I have 6.87, looks like 7 grams of oxygen there. So that's where that number comes from. Now this would be great if it was the end of the problem, but alas, this is just the beginning. Oh man, this is why this is quite the problem at the end. Anywho, what we found now were the old givens for the problems that we saw yesterday. This is kind of where this comes from. So now I'm gonna find my ratio of moles for the stuff in my formula. My ratio of moles is gonna include some carbon, so I'm gonna use my grams of carbon. It's going to include some hydrogen, so I'm going to include that, and it's going to include some oxygen. Now, a chemical formula is not a ratio of grams, it's a ratio of moles. So I'm going to have to find my moles. So here we go again. I'm going to take the 5.1694 grams of carbon, change it into moles, and I get that. Hydrogen, change it into moles, and I get that. Oxygen, change it into moles, and I get that. Now, these numbers here, maybe you can ballpark them. After all of this, I want some reassurance here. So I'm gonna divide by the smallest mole amount present, just so I'm extra sure at what that ratio is. And when I divide by the smallest, I get a 1:2:1 ratio. So my empirical formula is CH2O. Cool. Now the optional problem at the end, this is again, just for those of you that are really reaching for the stars, you're like, huh, that's kind of neat, maybe I'll do one more. Here's the optional problem at the end. Again, CO2 and water. With my CO2, I'm gonna change grams of CO2, 44.01 grams for every 1 mole. For every 1 mole of CO2, there's 1 mole of carbon. For every 1 mole of carbon, there's 12.01 grams, and I get 0.0701 grams of carbon. With my water, 0.0350 grams, change it into moles. Every 1 mole of water, there's 2 moles of hydrogen. Every 1 mole of hydrogen, there's 1.01 grams, and I get a really tiny number for hydrogen, 0.00392. Now I know that my sample was a pretty small amount, 0.105 grams. That was made up of carbon and hydrogen and that oxygen. So I'm gonna use the numbers that I just found to help me figure out that I'm gonna have 0.03098 grams of oxygen. You can take yours to more or less decimal places, that's totally fine. Now again, this isn't the end of our problem. This is just the beginning. Don't worry, not every problem is quite like this in AP Chemistry. This is probably the most calculator heavy thing we do for like the first 2 months. So there you go. Anywho, with this one, oh, there's my gram amounts. I worked so hard for it. Now I'm gonna change them into moles because I need a chemical formula. So I need a ratio of moles. So there's how I do that there. Divide by my molar masses. I get some pretty small decimals. And again, my brain is totally fried from having to do all of this work. So I want the reassurance to divide by the smallest. I can't eyeball this. This is quite the problem. Now, when I divide by the smallest, I get a 3:2:1 ratio. And so my answer for this one was C3H2O1. The molecular formula step was omitted from the problem just because I didn't want to scare you off too much at this point. Awesome.